Hello students, welcome back. We did most of the problems from section 4, but just a couple more will not hurt. So we talked about this one and that one. You see, greater than something is 0.325. So that means less than that something is 0.675, the complement probability. And look up appropriate z-score associated to this one, and that turns out to be about 0.537 something, 0.454 or 0.455, something like that. And then you can set up appropriate equation to that. That is x minus center 16.75 over 0.451 is equal to, or more precisely speaking, approximately equal to the z-score you estimated, 0.454, or maybe just 0.45. And then, so for this x value, that shouldn't be too hard. If you do it right, you're going to get this kind of computation. And in the end, you're going to get this kind of answer. What if we have between something and something, but this something happens to be 16.75, precisely the mean, so it's easy. The left-hand side is just 0.5, so from here to there, all the way is 0.775. So it's the same type of problem as the first problem, except instead of looking up 0.25, you'll have to look up 0.775. How about this? Well, the middle part is 0.95. So the other 0.5 or 0.05 will be shared by the left-hand side and right-hand side. So add these up. What do you get? I get 0.975. And that's what this is, 0.97. Wait a minute. Oh, excuse me. I didn't do 0.975. I looked up 0.025, this one, 0.025. So if I look up 0.025, the z-score will turn out to be, let's see, 0.025, yeah, right here, 0.025, and there's negative 1.96, negative 1.96. So instead of looking up this right-hand side and then looking up 0.975, I could have looked up this one, left-hand side, and then get negative 0.96. And how about this one? By symmetry, positive 0.96. Yeah, okay, this method is probably a little bit easier to understand than the one I did in section 3. In any case, we get plus or minus 1.96, and we get this kind of computation. In summary, we can do things like this. Step 1 is always drawing a normal picture. Outline, center, and shade. That's what we do. And then find the nearest z-score from the table based upon what you want. And then you can set up appropriate equation. N minus center over SD is equal to something. So for example, if you're looking for end, then you're going to get x minus something, center value, in this case 16.75, but it could be any other problem, and over SD value. And then that's equal to approximately, and then the z-score, which you looked up and found out. Let me use just this. What do you have? You have an equation with one variable. flip the denominator, flip this center to the other side, and then you're going to get an x value. Now, what if you want the center and you know the end? Then it's going to be this. End value is given from the problem, and this is what you don't know. So let's call this one as x, and then solve this equation. Again, this is an equation with one unknown variable. You can solve it. Remove the denominator to the other side, and then flip, you can find out. Another situation is when you have to find out the standard deviation, the denominator. Again, no sweat. This is known. This value is given. That value is given there. And standard deviation, you don't know this one. And here, we end up with an equation of one unknown variable, but it's in denominator. Will that cause a bit of trouble? No, not really. Not really. Multiply s to the other side. Then you're going to get this. So multiply s to left hand side, denominator disappears. To the right hand side, we get that. So what do we have? We have an equation. End is a certain number, center is a certain number, that too is a certain number. We have an equation to solve with a bunch of dirty decimals, so you have to do a bit of a calculated work, but this is a kind of thing you should be able to do. Exactly how? Well, we're going to discuss those kind of problems in section 5 in a little bit more realistic setting. So don't be anxious, please be patient, because yes, we will come back and discuss all those. Every single one of those. Okay, so much for all those examples in section 4. I'll say that's complete, and let's meet again in section 5 in a separate video. Stay tuned.